Okay, welcome back to Mrs. Riley's Maths videos. I'm here doing circle geometry and I'm working from texts and test 2 exercise 16.3 on page 330 and just 330 actually. And I've been asked if I would go through questions 9 part 2 and 3 and question 10 part 3. So I've drawn out the diagrams so I can write on them and you can follow what I'm doing. We're being asked to find ACB, that angle, OCA, so I'll have to draw a line there in a minute, OCB, and OBC. Okay, so we're being asked to find 4 angles in this, and there's Ray helping us out. So, angle ACB is the first one. That's probably the easiest one. This angle up here is ACB. Okay, and let's just colour it so that we know which one we're talking about. So angle ACB. So angle ACB is on this arc here. Let's fill that in. This arc. Okay, and it is the angle at the edge. The angle at the center on the same arc is this one, 140. So remember, we're talking about the theorem where the angle at the center is equal to twice the angle at the edge on the same arc. So this angle AOB is twice the measure of this angle ACB. So ACB is going to be 70 degrees. It's going to be 70 degrees because it's equal to a half of 140 degrees. So that's angle ACB. Angle OCA, so to do this one we're going to have to draw a line from O to C and A. So let's just draw that line. So what we have here now is this triangle OCA. Let's just draw it here. OCA. Now OCA, this is the center of the circle. OA is a radius. That means it's the same as length OC because it's also a radius, which is the same as length OB, which is also a radius. So OC and OA are the same size because they are both radii, which means that OAC, this angle here, and OCA, this angle here, are the same size. So this is the one we're looking for. OCA, this angle here. So OCA is equal to the same size as angle here, 30 degrees. So this is 30, we were told that. So this is 30 because it's an isosceles triangle, because these are both radii. So OCA is equal to 30 degrees. Isosceles. OCB, so let's draw that one. OC and B. Well, this angle here is going to be 70 degrees minus 30 degrees because this part of it is 30. The whole thing is 70. We found that out at the start. So that's going to be 40 degrees. So OCB is 40 degrees. And then finally OBC. Well, this is OBC, so actually didn't do a color for that. OCB is this one here, and then finally, this is 70. Finally, what am I doing? OBC, so that's this one here, which is this one here, and this one here. So again, this is an isosceles triangle because OC and OB are both radii. So this angle and this angle are the same. So if this angle is 40 degrees, then this angle is 40 degrees. Okay, I hope that makes sense. Go back over it again now if you need to. Next question, 10 part 1. Let's zoom in a bit here. So we have two angles marked in this already. We have 30 and we have 100 degrees. And I have somebody here trying to get Ray back on screen. So there's Ray back on screen for a moment, but she'll have to move. So there she is back on screen. Thanks for that. And what have we been asked to find? We've been asked here to find x and y. So here's x and here's y. These are the angles we've been asked to find. So angle x. So the first thing to say again is this is an angle and it's on this arc. And this angle is also on the arc, but this one's at the center and this one's at the edge. So we know this angle here is twice this angle here. So angle x, measure of angle x, the pink angle, that angle is going to be 100 divided by 2, which is 50 degrees. So angle x is 50 degrees. Okay, that's the first thing. The second thing to say then is that if that's 50 degrees and this angle here is 30 degrees, well, we can basically do the same thing we did a minute ago in question 9. So we'll end up with this triangle, which is 30, and this up here is also 30 because these are isosceles. Let's call this A, B, C again. So A, O, B, that's 30. Okay, and if the whole thing is 50, then this bit here is 20. Okay, so this bit to the right, so if I draw that triangle, O, B, C, not a great drawing, hang on, let's try again. O, B, C, so O, B, C, this must be 20, we've decided, because this and this, if I divide that down the middle, these two bits here add up to 50, we've just said. We know this one's 30, so this one must be 20. And then this is an isosceles triangle, so that also must be 20. Okay, so angle y, measure of angle y is 20 degrees. Okay, again, because it's another isosceles triangle. Okay, I hope that's beginning to make a bit more sense now. Okay, so now going on to 10 part 2. Similar again, I think, probably, isn't it? So we have 25 degrees here, we have 35 degrees here. So I think what we'll do, we'll just call these again A, B, and C. And we'll probably have to split this like this, do we? So we have a triangle here that's got, and I'll call that O, O, A, B. And we have another triangle the other side of it, which I'll just draw here, which is O, B, C. Okay, so in this triangle A, O, B, we know this angle, sorry, this length here, OA, and this length here, OB, are both radii. So this is an isosceles triangle. So this angle 25 will be the same as this angle 25, if you can see that. And then this triangle OCB, this angle 35 will be the same as this angle 35, because again, this is a radius and this is a radius, so it's another isosceles. So in both those cases, we have two isosceles triangles. This one, angle 25 here, so angle 25 here. Okay, so this is 25, angle 35, angle 35. So those two angles together are going to be 25 plus 35. So angle x is equal to 25 degrees plus 35 degrees, which is 60 degrees. Because it equals 25 from this triangle and 35 from this triangle. So those two angles together form angle x. It's equal to 25 plus 35. And then once we have that, we know angle y then. Well, angle y is on this arc. Angle y is on here. And angle x is also on here, angle y is at the center, so it's twice the measure of the angle at the edge. So y is twice x. So y is equal to twice x. So y is equal to twice 60 degrees, which equals to 120 degrees. Okay, and then finally, 10 part 3. So here we have a strange situation. So what we have is we've got an arc here, and we've got two triangles drawn on that arc, or two angles drawn on that arc. Here's angle x drawn on that arc, and here's this other angle, 36 degrees, drawn on that arc. So trying to find x, well, we know that angles that are at the edge that are on the same arc are the same size. So we know this angle and this angle must be the same size. So the first thing is x is equal to 36 degrees. So x is equal to 36 degrees because it's on the same arc. So if x is 36, we now have a triangle that is this triangle. That's y, that's 36 degrees. Let's call it A, B, C, A, B, C. Now, it looks the way that I've drawn it like it's a right angle triangle, but how can I know if it's a right angle triangle? Well, I can know it's a right angle triangle because that's where O is, which makes that the center of the circle, which means both of those are radiuses. So the whole thing is a diameter. And if you remember that theorem that we did about the angles on the same arc said that if we had a diameter and an angle on that, a triangle on that diameter, so the corner of the triangle is at the edge and the base, or the one side, in this case the hypotenuse of the triangle, is the diameter, then this angle must be 90 degrees. So this is 90 degrees and this is 36 degrees, so y would have to be whatever is left over from that. So 90 plus 36 is 126 degrees, so y is going to be 180 minus 126 degrees, which is what, 54 degrees. So y is equal to 54 degrees. Okay, I hope that helps. Have a look back over it and get in touch with me if you're still not getting it. Thank you.